Welcome, Algebra 1 students, to Unit 1.4, the properties of real numbers, with a focus on multiplication. You're hearing the voice of Mr. May, and I will be your teacher that is going to guide you through this particular unit. As always, please have your guided notes with you. You will be completing them as we work through the lesson. Make sure that you use the pause button and the rewind button to fully engage in the content. Make sure that you understand it and that you are keeping track of filling in the guided notes correctly. So moving on to our learning targets. We have 6 learning targets, all of them using properties, in this case with multiplication. We're going to learn to use these properties, but before we can learn to use them, we do have to learn what they mean, the terminology involved with each of them. We have learning target number 1.4a, which is I can use the commutative property of multiplication to find the product of real numbers. I can use the associative property of multiplication to find the product of real numbers. Learning target 1.4c, I can use the identity property of multiplication to find the product of real numbers. Learning target number 1.4d, I can use the inverse property of multiplication to find the product of real numbers. Learning target number 1.4e, I can use the multiplication property of 0 to find the product of real numbers. And finally, learning target number 1.4f, I can multiply real numbers with same and different signs. For those of you that may have already watched and learned Unit 1.3, which was the properties of real numbers focusing on addition, may notice that there are some similarities between the properties of addition and properties of multiplication. Some of that will carry over from the addition unit, Unit 1.3, into this unit. However, there are a few that there are some nuances that we must pay attention to make sure that we do not confuse some of the properties of addition with multiplication. So please pay close attention to some of those subtle changes between the properties of addition and properties of multiplication. So let's consider 3 times 7 and 7 times 3. Think about what that expression would equal, or actually simplify to. So 3 times 7 is 21. 7 times 3, looking over here, 21. We have 6 times 14. 6 times 14 is equal to 84. 14 times 6, also 84. For those of you that may have watched Unit 1.3, think about what property we could be discussing. And the property we are discussing is the commutative property, in this case of multiplication. I want to highlight that this property holds for multiplication, not division. And so we must make that distinction in order to use the commutative property. Now the commutative property, similarly to the commutative property of addition, the order of the terms can change without changing the value of the expression or the equation. And so when we look at our terms that are in our generalized equation, A times B is equal to B times A. The order changes, the value does not. And when we once again consider why the name, I will refresh you on the example that I gave with the commutative property of addition. If I live in Danville and I still own my little pickup truck here that I drive around, okay, got a little exhaust, and I drive over to Lexington to work. I commute. There's the word commute to Lexington, about 42 miles approximately. When I return home, I commute back home. I'm not going a different distance. Even though the order that I'm traveling changes, the value of my distance that I'm traveling does not. I'm still traveling the same 42 miles despite the change in direction of the commute. And so that is how, using that analogy, we can remember the name of this property and what it implies. So a couple of examples. We have pretty much an unlimited number of choices. So we could say 5 times 7 is equal to 35. And so is 7 times 5 equal to 35. We could say 11 times 3, which is equal to 33, is also the same as 3 times 11, which is also equal to 33. The order changes in the terms, but the value does not. Consider, secondly, these sets of expressions. They may have some similarity to what we may have done with the property of addition, but using the order of operations, if we have 5 times 4, 5 times 4 is 20. 20 times 10 is equal to 200. Looking at the expression on the right, 4 times 10, using the parentheses as our first order of operation, that's 40. 40 times 5 is also equal to 200. What you may notice is that the grouping changed. However, the value did not change. So although the grouping changed, the value did not. So second example, 12 times 18 times 100 is equal to 21,600. 18 times 100 times 12 is also equal to 21,600. And so you may recall that there was a similar type of property with the properties of addition, and that property was the associative property. And so we also have the associative property of multiplication, and this once again refers to multiplication, not division. So we have to make that distinction. With the associative property, the grouping of the terms changes. So we can change the grouping. We have our generalized example where all the terms remain in the equation, that they are just grouped differently. The analogy that I gave with the associative property of addition was if we have our grouping of friends and we have 4 friends just hanging out here. Each one of them had on a different shirt. So we'll give a blue shirt, a red shirt, a green shirt, and a black shirt. And if we were to group these two together and these two together, we have 2 groupings, right? They're associating right now with a smaller group to have a conversation with, a group of 2 and a group of 2, but the total, the value is still 4. And if we change who our friends associate with at the moment, so even if we change that association of who they're hanging out with, and there's the last one, they associate or they're grouped differently, but the value has not changed. So think about the friend analogy. when you are making an association with the grouping of terms and how it might change and the property that you're using of multiplication. Now, as an example, we could use 3 times 2 in parentheses times 10, and that is equal to 3 times 2 times 10. All I'm doing is changing the grouping. So this would be 6 times 10, which is equal to 3 times 20. So 60 is equal to 60, showing that the associative property for multiplication holds. Consider now 5 times 1, 12 times 1, and negative 3 times 1. I'm confident that you have more than likely determined the solution of each of these to be 5, 12, and negative 3, but can you describe the behavior of these equations? What is a general statement that you can make about all 3 of these equations? Well, notice each of these equations has a 1 being multiplied by a number. And what is happening is that when you multiply by 1, the value of the number does not change. Referring back to Unit 1.3 with the property of addition, there was a similar property of addition, but it did not involve a 1. But it did involve a number maintaining its value. The property that I'm referring to is the identity property. And so with the identity property, a number has an identity based on its value. In this case, 5, its identity is based on its value of 5. When multiplied by 1, it does not change its identity. It does not change its value. The same for the 12 and the same for the negative 3. It does not matter if it's a positive or negative number. When multiplied by 1, it does not change its identity. And if you're curious as to the similar but not exact, this is one of the nuances that I was discussing earlier. The identity property of addition does not add a 1. It is the addition of 0. So the identity property of addition, remember, 5 plus another number 0, the 0 does not change its value. The 5 maintains its value, therefore it maintains its identity. So while they are similar, the identity property of multiplication and the identity property of addition, they are not exact. So make sure that you remember that distinction. And we have discussed the identity property of multiplication. We went to it a little bit more in depth in the previous slide. But what we see is that, once again, focuses on multiplication. I do want to point out that the word product refers to multiplication. And then we are multiplying a value by 1, and it maintains its value. It maintains its identity. So maintains value and identity of the number being multiplied by 1. So that's how you can remember the property, the name of the property, but more importantly, what it does and how you can use it in the future. So an example can be choosing any number 4,326 times 1 is equal to 4,326. Does not matter if it's a positive or a negative number being multiplied by 1. It still maintains its identity. It does not change signs. It does not change value. It maintains its identity. So the identity property of multiplication. Consider these examples. Now we've introduced fractions. Now I want to briefly discuss the introduction of these fractions. What these fractions are actually doing is, in some way, it is the same as dividing. Okay, so multiplying by 1 over 6 is the same as dividing 6. Multiplying, let me go back here, let me erase just so we can see. So if I take a number 6, and let's change the color so I can see it really well. So if I take this number 6 and I multiply it by 1 divided by 6, that is the same as, let's move it over here, that is the same as 6 divided by 6. So similarly to where we have subtraction is the same as adding a negative, we can say the division is similar to multiplying by a fraction. Okay? And in this case, the reason we want to be able to do that is twofold. One, the properties do not hold for division. And so if we can multiply, we can use our properties in order to solve equations and simplify expressions. But it also has a particular property that we want to highlight here. And notice some similarities between each one of these equations. Take a moment and see if you can see what it is. First thing you may have noticed, each one of these is equal to 1. Another aspect that you may have noticed is that there is a 1 in each one of the numerators. And then lastly, recognize that the number in the denominator is the same as the number that is being multiplied by the fraction. And so what we call this number, that is the fraction in this case, we call this a reciprocal. And let's see if I can spell that correctly. Reciprocal, okay? So this is the reciprocal of 6. Now, if I were to turn this original 6 into a fraction, what I would do is I would put it over a 1. 1 would be in the denominator. The same thing with the negative 20 and the 3. And what a reciprocal is just the switching of the numerator and the denominator. And so what has happened is that the 1 has gone to the numerator and the 6 has gone to the denominator. It's the reciprocal. And so when we describe the behavior of these equations, what we can say is that multiplying a number by its reciprocal results, and actually I'm going to change that result. I like equals 1. So anytime you have a number and you multiply it by its reciprocal, it will equal 1. This property is called the inverse property of multiplication. Now, as you recall, we also have an inverse property of addition. Please do not confuse the two. The inverse property of multiplication is the multiplication of a number and its reciprocal. The inverse property of addition, and I'll write it over here just so you can recall, the inverse property of addition, that is a number that is added to its opposite to equal 0. Okay? Remember we talked about how inverse was similar to the word opposite, and so you take a number, you add it to its opposite, and you get 0. That is the inverse property of addition. Please do not confuse it with the inverse property of multiplication. Okay? And so why the name? The name again is talking about using this word inverse and how the reciprocal is connected to the word inverse. So whenever you see, in general, a number, let's just do that with all of them, that is multiplied by its reciprocal, the answer will always equal 1. So let's do an example. And the number 10. Well, the number 10, the reciprocal of 10 is going to be, if I had to turn 10 into a fraction, I would put 1 in the denominator. Well, that 1 has to move to the numerator. 10 goes to the denominator, and that is going to equal 1. And if I were to work this out, let's think about it, just so you can really visualize and see what's going on. If I multiply fractions, what I do is I multiply across. And so if I were to multiply across, 10 times 1 is equal to 10. 1 times 10 is equal to 10. There's the commutative property. 10 divided by 10 is 1. And so that shows how we're using the inverse property. Now I want to give you another example that does not involve a 1, because we can use this with any reciprocal. So let's say 5 divided by 8. Okay, that's our number. The reciprocal of 5 divided by 8 is going to be moving the 8 to the numerator, the 5 to the denominator, and using the inverse property of multiplication, we know that the answer is going to be 1, but let's look at it a little closer and see why. We're going to multiply, wrong thing. We're going to multiply the 5 times the 8, and we're going to multiply the 8 times the 5. Well, 5 times 8 is 40. 8 times 5 is 40. 40 divided by 40 is equal to 1. So that is why the inverse property shows that the number and its reciprocal, when multiplied, will have a product of 1. Please, once again, please do not confuse that with the inverse property of addition, which is a number and its opposite added will equal 0. Looking at this set of equations, let's consider, you may already have determined the solution to each one of these. 5 times 0 is, tempting as it may be to say 5, it is actually equal to 0. 12 times 0 is equal to 0. negative 3 times 0 is equal to 0. And so what we're seeing, if we were to describe the behavior of these equations, looking at the similarities, what do we notice? First, yes, they're all equal to 0. Secondly, they're all being multiplied by 0. And so what this can tell us is that a number multiplied by 0 equals 0. Now, this particular property becomes easy to confuse with the inverse property of addition. I'm going to go back one slide. Notice that the inverse property of addition also equals 0. It also equals 0. Okay? The confusion is you look and notice all of these equal 0, and you think, oh, it's the inverse property. Must be the inverse property of multiplication. That is not correct. As you recall, the inverse property of multiplication was multiplying by the reciprocal. So be very careful to make the distinction that a number multiplied by 0 is not the inverse property of multiplication. Okay, does not carry the same name. Okay, that actual property is the multiplication property of 0, exactly what it sounds like. Okay, it describes exactly what it is doing. So let's go ahead. Describes, why the name? It describes what is being multiplied. It's just we're multiplying by 0. And so very straightforward. The multiplication property of 0 states that a number multiplied by 0, its product will be 0. Here are the results of 0. This is the multiplication of any number. It doesn't matter if it's a positive number or a negative number. When multiplied by 0 will equal 0. And so a couple of examples. We can say 1010 times 0 is equal to 0. Negative 3,478 times 0 is equal to 0. And then any example that you may come up with as well, but I will do one more, and that is negative 15 times 0 is equal to 0. And so in each one of these, we can see that by multiplying by 0, the product will be 0, the multiplication property of 0. Consider this. 5 times negative 1, 12 times negative 1, and negative 3 times negative 1. So let's find our answers. So 5 times negative 1, negative 5. 12 times negative 1, negative 12. Negative 3 times negative 1, not negative 3, but a positive 3. And so can we describe the behavior of these equations? Well, first thing we may notice, we're multiplying everything by negative 1, okay? So we've got everything being multiplied by negative 1, and are we getting the exact same value? Well, we have a 5 here and a 5 there, but something is different, and that is it's now a negative. Okay, we have a 12 and a 12, but it is now a negative. 3 and a 3, but the negative 3 has become a positive 3. So remember that a number, when it changes to its negative or a negative number that changes to a positive, that is its opposite. Okay? So 5 is the opposite of negative 5, or in this case, negative 5 is the opposite of 5. Negative 12 is the opposite of 12. Positive 3 is the opposite of negative 3. So what's the behavior that we can describe? Well, a number multiplied by negative 1 results or equals its opposite. So 5 times negative 1 is equal to the opposite of 5, or in this case, negative 5. And the property that we just described is the multiplication property of negative 1. So why the name? Well, similarly to the multiplication property of 0, it describes what is being multiplied. And the reason we're talking about why the name is because we have to use these properties to justify some of the steps in the solutions of equations that we'll be solving in the future. So we have to be able to say, I use the property of multiplication property of negative 1. I use the commutative property. I use the associative property. And we've got to have a methodology for associating the names of the properties to what they are actually representing and what they are doing when we use them in an equation. And so again, the multiplication property of negative 1 tells us what is being multiplied. A number and negative 1 are being multiplied. And that is going to result in its opposite. And there's your negative 1s. And here's a number. And notice that when you multiply, you end up with the opposite of the number that is being multiplied. So an example, you can just say that 112 times negative 1 is equal to the opposite of 112, or negative 112. And a second example, negative 25 times negative 1 is equal to the opposite of negative 25, which is a positive 25. Multiplying same and different signs. Now there's several examples here. And I'm only going to work a few of them. Actually, I may work them all, but I'm going to work them relatively quickly just so you have the ability to check yourself. But I want you to work through them. Hit pause, work through them, and see if you can determine what is actually happening in each one of these examples that are being illustrated. And so go ahead and hit pause. Okay, now that you're back, let's go ahead and 12 times 4 is 48. So 2 times negative 11 is negative 22. 3 times 8 is 24. Negative 7 times 6 is negative 42. Negative 15 times negative 5. Negative 15 times negative 5 is going to equal to a positive 75. 21 times negative 5 is equal to a negative 105. And then negative 7 times negative 9 is equal to a positive 63. And so we could see what our answers are, but now we're looking at multiplying same and different signs. So let's go through, and I'm going to put positives over all the positives. Okay, positive. And let's see. There's all the positive numbers. I'm going to put a negative over all the negative numbers. Okay, now take a moment and hit pause and think about what the pattern is. Okay, did you figure it out by any chance? There's a possibility. So notice we have two positives and it equals a positive. So that might lead you to think, oh, you multiply a positive and a positive, you get a positive. And that is true, but there is something more generalized than that. Notice also when you multiply a negative and a negative, you don't get a negative. You end up with a positive. And so what happens is that when you multiply, these two signs are the same. Okay? You end up with a positive result. And let's see if that holds for all of them. Well, these two are the same, and we ended up with a positive. These two are the same, and we ended up with a positive. Okay, let's think about when they're different. Well, these two are different, these are different, and these are different. And what did we end up with? We ended up with negative numbers. So in the case of different signs, we end up with negative product or a negative result. And so this is a generalized way that we can understand how signs that are the same and different are multiplied. So looking at multiplying numbers with the same sign, multiplying a positive number and a positive number. So a positive and a positive number. So the product of two positive numbers, okay, two positive numbers, results in a positive number that is further to the right on the standard number line. So if we were to have a number line, I'm not going to go completely into detail on this, but if we have two numbers, I might go a little bit into this one. So let's see. And two positive numbers, so 0, 1, 2, 3, 4, 5, 6, 7, 8. If we have two positive numbers, 2 times 4 in this case is equal to 8. There's our result. And when we look at where it is on the number line, it is further to the right. Okay? So when we look at multiplying a negative number and a negative number, or two negative numbers, the result in this case is not a negative number. Remember, same sign is always a positive number with multiplication, and it will also be further to the right on the standard number line. And so if I were to give you the example of this, I guess we can quickly do that. If we have 0, -1, -2, -3, -4, 6, and 1, 2, 3, 4, 5, 6, 7. If I were to take two negative numbers, -2 and -3, and when you multiply two negative numbers, again, when you multiply numbers with the same sign, the result is a positive number. So -2 times -3 is a 6, and that is to the right on the standard number line. Multiplying numbers with different signs. So if we multiply a positive and a negative number, and so we're going to end up with a result of a negative number that is further to the left of the original positive number. And that seems to make sense because if we're going to end up with a negative number, it will be to the left of the positive number. But if we and let's see, -4, -5, and -6. So if we were to multiply a positive and a negative number, so here's our positive and our negative, let's say -2. Positive 2 times -2. Well, we know that multiplying numbers with different signs gives us a negative number. 2 times 2 is 4, so the result is going to be a -4. And -4 is to the left on the standard number line of the positive number. So to summarize, multiplying same and different signs, the product of two real numbers with the same signs is a positive number. Doesn't matter if they're two positives, so it could be positive times positive, or it could be negative times a negative. It does not have to be two positive signs. That will result in a positive number. The product of different signs will result in a negative number. And once again, that is a positive times a negative will equal a negative number. And just to equals a positive equals a positive, and this equals a negative number. Example number 1, highlighting learning targets numbers 1.4a, 1.4b, 1.4c, 1.4d, and 1.4e. Take a moment, hit pause, see if you can match the listed property with the corresponding expression. Again, these are the properties of multiplication we have discussed. See if you can match them. So go ahead and pause. When you're finished, go ahead and hit play, and we'll work through them together. So beginning with the first expression, or in this case equation, we have b times 0 equals 0. Well, what's going on? Well, we have multiplication by 0. And if we remember about why the name was it describes what's being multiplied. Well, in this case, we're multiplying by 0, so we have the multiplication property of 0. Looking at the next equation, we have a times b times c is equal to a times b in parentheses times c. Now at this point we should be very familiar with this property because it's dealing with grouping. And when we're dealing with grouping, we know that we are working with what is being associated with. Again, think about our friend analogy from both the associative property of multiplication and the associative property of addition. Looking at the third equation, we have b times -1 equals the opposite of b, or negative b. Again, this describes what is being multiplied, and we know that we're having a multiplication by -1 resulting in the opposite, which describes the multiplication property of -1. Moving to the next equation, we have a times b equals b times a. If we look at what happened, we have changed the order of the terms. Instead of going from Danville to Lexington, we are now coming back from Lexington to Danville. The value has not changed, despite the commute. That's right, changing the order of the terms describes the commutative property. Looking at the next equation, we have a times 1 equals a. Now the tendency might be to say, oh, this is describing what's being multiplied, a times 1. However, notice that that is only true for the multiplication property of -1. This a times 1 equals a is the one that I encouraged you to be very careful not to confuse with the similarly named property with addition. Let's look at what's happening. We have a, which has a value, being multiplied by 1, but maintaining its value of a. And when you think about why something was named, why the property was named, it's because it maintained its value, it maintained its identity. The a maintained its identity through its value. Once again, please do not confuse this identity property of multiplication with the identity property of addition. And then lastly, we can see that we have left, I think I'm just going to have to do a circle or an underline here. So I'll just put a box around it. We have the inverse property of multiplication, which is what is left. However, let's describe what's going on. We have a being multiplied times 1 divided by a, which is equal to 1. Now, if we want to change this a to a fraction, we will put a 1 in the denominator. We know that this 1 is in the numerator, and when we change the numerator to the denominator and vice versa and multiply them, we have the reciprocal. Okay, we have the reciprocal that we're multiplying by the original number, and that is going to equal 1. Again, we're multiplying by the reciprocal, that word inverse, this word inverse referring to the reciprocal. And that is why we call it the inverse property of multiplication. And again, another example of why we have to be careful not to confuse this property with a similarly named property of addition, the inverse property of addition. Because the inverse property of addition is adding the opposite. So make sure that you distinguish these properties from the properties of addition. Example number 2, highlighting learning target number 1.4f. So what we're going to do is multiply the numbers and state the direction on the standard number line. The result will be relative to the two numbers being multiplied. So what I want you to do is hit pause, work through the examples. When you're finished, hit play again, and I will work through them with you to see how well you're understanding the content. So go ahead and hit pause. And I'm welcoming you back because I know that you did work through this on your own. And so let's begin with 4.1 times 3.63. And that is equal to 14.883. Okay, now we know that we have multiplied a positive number times a positive number, and we ended up with a positive result. Remember, same signs have a positive result or positive product. And if we were to draw a number line, we would know that on that number line you would have approximately 3.363 here, 4.1 here, and then way over here somewhere on the further down the number line we would have 14.883, and in order to move there we would move to the right on the standard number line. Looking at the next example where we are multiplying 1.24 times, or negative 1.24 times negative 5.5 7, 1, we end up with 7.0804. This time, however, we multiplied a negative times a negative, but remember, it's not multiplying two negatives equals a negative. It's two of the same signs results in a positive. Remember, that's a same signs has a positive result, a positive product. And when we look at where 7.0804 is in relation to the two numbers being multiplied, we have once again moved to the right. Lastly, we have 2.31 being multiplied by a negative 5.12. And so our result is going to be 11.8272, but it's not going to be a positive. It is going to be a negative. And the reason being, we have a positive being multiplied by a negative, which means that we have different signs being multiplied, resulting in a negative result, a negative product. And so this negative is going to be to the left of both of the numbers being multiplied, but relative to the positive number, we still have moved to the left. And just as a point of review, while we have a moment, this is not this specific learning target, but I would like to review really quickly. Going back to Unit 1.1, the types of numbers that these results are, how would they be classified? Well, notice that they all have decimals. So that means that they are either a rational or an irrational number. And then a rational number either terminates or repeats. An irrational number neither terminates nor repeats. And so for that reason, we can say that all of our results in this case would be classified as rational numbers. That is not part of the question, but definitely something that we want to review and be aware of as we work through all of the units, because again, math always builds on previous content. So this concludes Unit 1.4, the properties of real numbers, focusing on multiplication. As always, please go back, review any content that you may need additional help with, rework the examples, review the guided notes, and if you have further questions, please come and ask one of the math teachers. We are more than happy to help you with any questions that you may have. I hope you have a great day and look forward to seeing you in class.